The figure shows the chain drive of a bicycle. We want to know how far the bicycle will travel if the pedals are rotated through 180 degrees. So what the figure does not tell us is, or does not show us, is the wheel that is actually doing the traveling. So this gear, larger gear, drives the smaller gear, which is connected right in the center to the wheel. And so the small gear and the wheel turn through the same angle. Now the arc length that the wheel passes through is what gives you the distance traveled, because as the bike moves, a certain arc length right here is going to touch the ground right here, and if we had paint marking that, then we would be able to identify a linear distance that the bicycle moved. So arc length here is going to be the distance traveled. Okay, now they do tell us that the radius of the wheel is 14.2 inches, and we're going to need that. But in order to find that arc length, we need the theta that this small gear turns through, and we don't have that. So we have to go to the large gear, and we're told that the pedals are rotated through 180 degrees. Our formulas use radians. 180 degrees is the same thing as pi, so we're going to use pi when we substitute in. So arc length is equal to the radius times theta, with theta in radians. The arc length for the large gear and the arc length for the small gear is going to be the same. They travel through different angles, but the arc length is the same. So the arc length on the large gear is equal to the radius times theta, which is pi. The arc length of the smaller gear is equal to the radius times some theta, which is what we're looking for. Since these arc lengths are the same, we're going to set their expressions equal to each other. You want to solve for theta, so divide both sides by 1.23. This gives me theta in radian mode, and now I know that this gear turns through this theta. And the wheel, since it's connected to that gear, turns through the same theta. So we can find the arc length of the wheel by substituting in the radius and multiplying by this theta that we found right here. So let's take that to the calculator and type that in. So the arc length that we get is equal to 177.354. And the units on that arc length would be inches.